Hey, this is lesson 8.1. If you have your textbook, you can go to page 318. But this is talking about a circle. A circle is a set of all points in a plane that are the same distance from a point called the center. So on a circle, this would be called the center, that dot in the middle. And the circle is all of the points that are a certain distance from that center. But we already knew what a circle was. The radius is from the center to the edge of the circle. It's halfway across the circle. The diameter is all the way across the circle. It has to go through the center, but all the way across the circle is called the diameter, and halfway across the circle is called the radius. In words, the diameter, d, of a circle is twice the radius, or you could say the radius of a circle is 1/2 of the diameter. So we have two formulas. We have diameter, which we use a d for that, is 2 times the radius, and the other is radius is, you could either put 1/2 the diameter, or you could put the diameter divided by 2. Both of those are the same thing, multiplying by 1/2 or dividing by 2. And then they give us a couple of examples here. If the diameter of a circle is 20 feet, find the radius. Well, if it's 20 feet across, that's the diameter. The radius would be half of that, or 10 feet. But I do want you to write down the formulas. So this says find the radius. So we'll be using this formula because this is the formula that shows us what the radius is. So for example 1a, it says the diameter equals 20 feet. And then we have to use this formula right here. So we need to find the radius. Radius equals 1/2 times d. And we know diameter is 20, so we plug that into our formula. Radius equals 1/2 times 20. And remember, times is of, so 1/2 times 20 is 1/2 of 20. Radius equals 10 feet. For example 1b, right over here, it says the radius of a circle is 7 meters. Find the diameter. So it tells us the radius equals 7, but we need to use this diameter formula. We have to find the diameter. So diameter equals 2 times radius. Diameter equals 2 times, we know r is 7, told us r is 7, so 7. Diameter equals 14. 14 what? 14 meters. And now we're supposed to do 2 on our own. The diameter of a circle is 16 centimeters. Find the radius. So we'll do that one down here. So it tells us the diameter of the circle is 16 centimeters, so we know d equals 16 centimeters. Find the radius. Well, if we're looking for the radius, here's the formula we'll use. So radius equals 1/2 times d. Radius equals 1/2 times, we know d is 16, so 16. Radius equals 8. 8 what? 8 centimeters. For number 2, the radius of a circle is 9 yards. Find the diameter. So it tells us the radius is 9 yards. And we're looking for the diameter, so we use the diameter formula. Diameter equals 2r. Diameter equals 2 times, well, the radius is 9, so 2 times 9. Diameter equals 18. 18 what? 18 yards. Excellent. Well, now we're talking about the circumference. The distance around a circle is called the circumference. We usually call the distance around a shape the perimeter, but circles feel that they're more special than any other shape. So we don't call it the perimeter when we're talking about a circle. We call it the circumference. Circumference. That's the distance around the circle. Remember, this is the diameter all the way across the circle, and this is the radius halfway across the circle. The ratio, circumference divided by diameter, or circumference over diameter, is the same for every circle and is represented by the Greek letter this shape right here, which we call pi. When the Greeks named it pi, they did not realize that this sounds a lot like what we call a pastry filled with fruit. But thankfully it does, because we celebrate Pi Day, where we eat pie. It has really nothing to do with this other than pies are circular, and it sounds like the Greek letter pi. The value of pi can be approximated as 3.14. It goes on forever and ever. It's an irrational number, so it doesn't stop. It doesn't repeat predictably, but we'll just round it to 3.14. And actually in class, we're going to solve in terms of pi. So the circumference of C of a circle is equal to pi times the diameter, okay? Or pi times twice the radius. And what that looks like in terms of a formula is right here. So if you'll recall, we did have two formulas. We had that the diameter equaled 2 times the radius, and we also had the radius equals 1/2 times diameter, which was the same as the diameter divided by 2. But now we have two formulas that deal with the circumference. So we have circumference either equals, I'm going to write this one first, I like that one better, 2 pi r, which means 2 times pi times the radius, or it's also equal to pi times the diameter. And that makes sense because 2 times the radius is the same as diameter. So really these say the same thing. Sometimes they'll give us the radius, and when we're looking for circumference, in that case we'll use this formula. And sometimes they'll give us the diameter when we're looking for circumference, and in that case we'll use this formula. In this first example, or example 2 part A, it says find the circumference of the flying disc, use 3.14 for pi. We'll actually just keep it in pi. And they tell us that, well, they didn't tell us, they show us that this is 5. So we have to remember that halfway across is the radius. The radius is 5 inches. So for example 2A, we're finding circumference. So we look down here and we think, okay, which of these formulas will I use to find circumference? This one right here. So circumference equals, and now I've got a choice. This formula, 2 pi r, or this formula, pi d. So I look and see what information they gave me. They gave me the radius. So I'll use this formula because it uses the radius. So circumference equals 2 pi r. And now I plug into the formula what I know. Circumference equals 2 just as 2, pi just as pi. But now we know that radius is 5. I solve what I can. Circumference equals, I know 2 times 5 is 10, so 10 pi. And then we'll put the inches on there. 10 pi inches. And we're going to leave it in terms of pi. We're not going to actually put that as 3.14 and do the multiplication. We'll leave it just like this. It's actually more exact this way. For example, 2b, so example, I'll put it down here, 2b. Find the circumference of the watch face, and now they give us the distance all the way across the watch face. And we remember that's the diameter. So we look up here, we're looking for circumference. And this time they did not give us the radius, they gave us the diameter. So we'll use this formula here, pi times diameter. We'll plug into the formula what we know, pi equals pi, we'll just put that, and the diameter is 28 millimeters, so pi times 28. Because we're treating pi as a variable, we don't leave it pi 28, we turn that around and we call it 28 pi. Well, that's pretty easy. We do have to put the units on there, millimeters. Well, here's a couple they want us to try on our own. Number 3. We are finding the circumference, so I know it's C equals, and then let's look at what information they gave us. They gave us the radius. So we look up here, we're going to use one of these two. This is the one where we use the radius. So we'll use that, 2 pi r. And we'll plug in the radius they gave us, 2 centimeters. 2 times 2 is 4, so this equals 4 pi, and the units were centimeters. Number 4, circumference equals something. Let's look at, see what they gave us. They gave us the diameter this time, all the way across. So we have our choice of this formula or this formula. We'll use the one with diameter in it, pi times diameter. Pi, we know the diameter is 14. And we don't leave it that way, we have to turn it around, so it's 14 pi, and it was feet. One more, number 5. What did they give us here? It's all the way across, so that's diameter. So we'll use circumference equals pi times diameter again. Circumference equals pi times 9. Circumference equals 9 pi, and it is inches. Fantastic. Well, the last part of this lesson is finding the perimeter of a semicircular region. It's called a semicircular region because it's a half a circle right there. And it's called perimeter because it's not a circle anymore. Remember, it's circumference when it's a circle. It's not a circle. It's kind of like a circle, but kind of like a circle is not a circle. So we call it back, we're back to perimeter now. So finding the perimeter of a semicircular region. Let's put our formulas back up here again. We had diameter equals 2 times the radius. We had radius equals 1/2 the diameter, or diameter divided by 2. And we had circumference was 2 times pi times radius, which is the same as pi times the diameter, because 2 times the radius is the diameter. And then we have this here. A semicircle is 1/2 of a circle. Find the perimeter of the semicircular region. So it says the straight side is 6 meters long. The distance around the curved part is 1/2 the circumference of the circle. So if that were a circle, we're talking about half of it, and then this distance is the diameter. So if you think about it, when I think of perimeter, I think about walking along and having to go all the way around it. So if I started here and I'm walking this distance right here, I have walked half of the circumference of a circle. But that doesn't get me all the way around this figure. Then I have to walk back to where I started. So let's take this in 2 parts. Let's do the half the circumference. Okay? Well, if circumference is 2 times pi times radius, then half the circumference would be 1 times pi times radius, or just pi times radius. So for half the circumference would equal pi times radius. Well, we're not all done. Remember, we got to get all the way back across here. If this were a full circle, we'd be walking back the diameter of this. Okay, the length for this purple one right here would be 6. So we walk back the diameter. So we'll call it the diameter, even though it's not actually a circle, but we know what we're talking about, that distance right there. So half the circumference is pi r, and then we have to get back. So to go all the way around this, I'm going to call it perimeter. And then I always like to put the shape that I'm talking about. It looks like a little turtle shell, but that's just a semicircular region. I'm going to have to do pi times radius. That'll get me that half circle, plus add the diameter back on right there. So pi times radius is this part. The diameter gets me back across to where I started. So let's give that a try. Here's our new formula. The perimeter of this semicircular region equals pi times the radius plus the diameter. So let's try the one they gave us. I'll put a 6 in here. 6 meters. Here's our formula, and now we'll plug into it. So pi, or perimeter, pi times the radius. Well, let's look at it. If all the way across is 6, then what's half the way across? It'd be 3. So the radius here would be 3. So pi times 3 plus the diameter. And remember, diameter is all the way across, so that'd be 6. Well, I have to clean this up a little bit. Perimeter equals, remember I turned this around, pi times 3 is 3 pi plus 6. And what do I get when I add these? That's right, I can't add these. These are unlike terms. I have a pi term and a constant. It doesn't have a pi variable on the end here, okay? So I cannot combine these. What I will do is I'll put meters on there. If I just put meters like this, it would only apply to this 6. So I actually put this in parentheses, and I put meters on the outside. That way it applies to the whole thing. So the answer here for the perimeter of this figure, for example 4, is the perimeter is 3 pi plus 6 meters. Let's try the 3 they gave us at the bottom here. So for number 7, we'll put the formula down. Perimeter of this semicircle equals pi times the radius plus the diameter. So pi, the radius, well, it's 2 feet all the way across. And if it's 2 feet all the way across, that's the diameter. Half the way across would be 1. So pi times 1 plus the diameter. And the diameter is 2. That'll equal, remember I can turn that around. I can put 1 pi. That'd be the same as pi, but I am going to put 1 pi just so we know what we're doing here. Plus 2, all in parentheses, and the units. Feet. Number 8. Same thing. It's flipped upside down, but no big deal. So perimeter of this semicircular region is pi times radius plus d. Pi times the radius, well, it's 7 feet all the way across. So half of 7 is 3.5, or 3.5, plus the diameter. Diameter is all the way across, so that's 7. So perimeter equals 3.5 pi plus 7, all in parentheses, centimeters. And finally, number 9. Perimeter of the semicircle equals pi radius plus d. Pi, well, they give us the radius here, 15 inches. They're showing it only goes halfway across. 15 plus, and if it's 15 across halfway, all the way across will be 30. So the diameter would be 30. 15 pi plus 30, all in parentheses, inches. Fantastic. Okay, so boys and girls, you should be able to now go ahead and do the journal page 170, which is lesson 8.1, the practice. 1 and 2, you're just going from either diameter to radius or radius to diameter. 3, 4, and 5, you're supposed to find the circumference of the circle. Remember, we're solving in terms of pi, like in the lesson. We're not actually substituting 3.14 in there. We'll have the symbol pi. For 6 and 7, we're finding the perimeter of the semicircular region, so half the circumference, and then add on the diameter. I know it's not really a diameter because it's not a full circle, but when I'm talking about the diameter, I'm talking about this length right here. So it'll be half the circumference plus the diameter. And then for this last problem, simple impact crater on the moon and a complex impact crater, what you're going to do, it says how much greater is the circumference of the complex crater than the simple crater. You'll have to find the circumference of both of these circles and subtract them to see how much greater the larger one is than the smaller one. So you should be able to do this. There's a video with this homework on there, so you can go to that video and watch that. Have a wonderful night.